Welcome to Patcher Day number 14. Today I'm going to use an OSC bank driven from the Sigmund object that we saw in one of the earlier Patcher Days, and I'm going to use that OSC bank. I'm going to have it be able to morph between one set of peaks from the Sigmund to another set of peaks. Okay, I'm going to use my microphone input. So I'm going to get an easy ADC. I'm going to use the, I'm going to want to hear something, so I'm going to make an easy DAC. Okay, and in between here, the first thing I'm going to pull up is a new object, and I'm going to pull up one of these Sigmund objects. Again, this was in an earlier patch day, but if you, I'm looking to go to Vegas next week, but if you just type in Sigmund max/MSP, it'll probably bring up this page with the Sigmund object. Put the MXO object somewhere down there in your somewhere down there in your the folder where it can find it. Oh, I went through this in an earlier patch today, so you go back and just look at that. As we saw last time, you can put these arguments into a Sigmund tilde to look at how many peaks you're going to analyze. I'm not entirely sure how many peaks I want to analyze in this case. Let's try something big like 64 peaks, see how that works. Every time I get one of these lists of peaks out of here, I'm actually going to just do a kind of audio freeze thing again, like I did a couple of patch days ago. So to do the freezing thing, I'm going to set up a toggle on a gate so that these things are gated. And when I click on the gate, I'm just going to delay 20 milliseconds or so, some very short amount of time before, with a message 0, close the gate again. So it's kind of you'll probably won't even see it. Like if I do this, yeah, you can barely see the fact that I've clicked the gate before it's automatically closed again. We can just quickly check that this works if we unpack. Remember that the first number out was an index, the next number out was a frequency, next number out is an amplitude. This is the peaks coming from the Sigmund, and we can just check if we just try hooking these up to an OSC bank. We'll use 64 oscillators, 64 frequency smoothing, who knows what that means, 512 amplitude smoothing, whatever that means, and 4096 as to the size of the wave table that's loaded in there. You can just check, this goes into the index, this goes into the frequency, this goes into the amplitude, and this turns on, and we should hear when we click this some kind of frozen audio, very much like the very much like the frozen thing we did on the seems like some things are getting stuck. Maybe I'll make this a little longer. Oh, that's just the feedback. Okay. So that's all working pretty well. Now what we want to do is figure out a way, instead of just sticking these straight in, so I'll disconnect all that, into our OSC bank, we want to be able to store this list coming out of this thing and be able to interpolate between one setting and the next. There is actually something called, it won't exist in my world, but list interpolate, I think. It's available somewhere out there in the SynMat set of externals. You could use that. I've used that before. But instead I'm going to use a matrix to store these values. And if I create a jit.matrix, it's going to need two planes, one to store the amplitudes, one to store the frequencies, and one to store the amplitudes. I'm going to make it float 32 because that's not even an L. Float 32 because we are using floating point values. Well, these frequency and amplitude values are floating point. I'm going to make it 64 by 1 dimensions because we have 64 peaks and we're really just going to store those along the x-axis. Let's call it the x-axis anyway. And again, the message that we'll use for the setting these frequency and amplitudes is set cell $1, which is the which cell it is. I guess we could put a 0 here, although that didn't seem to matter. Yeah, that's the cell which will be along the x-axis, and we'll give it the value of the next two values, the next two things in the list. So that we'll just use, I mean, that should just work directly off there. Then to actually get something out of this JIT.matrix, we're going to, I suppose, use a button, so B for button. And awesome. To actually make these things sort of change over time, I mean, right now we could just do this JIT.iter. So we're iterating out this list. Again, we need to unpack the dimensions. So we're only getting the x value, which is the only one that really means anything here. And then we're going to unpack this list over here of the frequency and amplitudes. And this should, according to my calculations, frequency and magnitude, as they like to call it here. All right, so this should, according to my calculations, work the same way. If I open that list up, let's set the matrix and bang out the matrix. And all my, the only thing this thing's doing is feeding back at this point. Maybe I'll grab a little silence there. Okay. So that's working exactly the same way, but we're just storing the matrix, storing the frequency and amplitudes in a matrix. To make this thing interpolate, that's the reason I'm using the matrix, the jitter, sorry, objects, is that I can use this thing called jit.slide to interpolate between the matrices, so that if we hook this in here, we can put that in there. And now, if I record one set, and so you can hear that one. And then another one, E. And then if we give it some slide up, slide down, which you'll see in the help, it will actually change from one to the other. Slide up, slide down. Move it all over a bit. Maybe, do we want to slide down? I don't know. So we'll give it a time value or a number of frames to slide up to, some change values basically. Oh. Okay, so this will work a lot better if you don't have your microphone going into your speaker as I do. The other thing that you might be interested in doing is recording a set of these matrices, which you can do using write and a write message, and then later on you can use a read message, an easy and cheap way to store these analysis windows, if you like to call them that. Use those, write and read them to make something happen over longer periods. All right, that's that for this week. Cheers.